morning, students. In this lecture, we will solve the remaining question of chapter number 2. Okay. So, question number 6 is saying that there are three capacitors of equal capacitance 9 picofarad and they are connected in series. Okay. So, the formula for series combination is 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, because the value of all the capacitor is equal. So, 1 upon C equivalent is equal to 1 upon 9 plus 1 upon 9 plus 1 upon 9, and we get 3 upon 9, 1 upon 3. So, the equivalent capacitance we get 3 picofarad. 3 picofarad means 3 into 10 to the power minus 12 farad. Okay. Now the B part of this question is asking about the potential difference across each capacitor. For this, we have total potential V1 plus V2 plus V3, that is equal to 120 volt. Okay. So V1 is equal to Q upon C1, V2 is equal to Q upon C2, V3 is equal to Q upon C3, because in series charge remain same. Okay. So put the value of all the capacitances. We get Q upon 9 into 10 to the power minus 12. Same Q upon 9 into 10 to the power minus 12, and same for C3 equal to 120, and by this we get Q is equal to 360 into 10 to the power minus 12 coulomb. Okay. With the help of this, we get potential difference across each capacitor by the formula V is equal to Q upon C, because the charge on each capacitor is 360 into 10 to the power minus 12 coulomb, and the capacitance of each capacitor is 9 into 10 to the power minus 12. So the potential difference across each capacitor is equal to 40 volt. Means the potential is equally distributed. Total potential is 120 and there are three capacitors. So the potential is equally distributed among the capacitors. Okay. Now in question number 7, three capacitors are also given. The value of capacitors 2, 3 and 4 picofarad, but they are connected in parallel. And for parallel combination, the formula is C1 plus C2 plus C3. So the equivalent capacitance we get 9 picofarad. Okay. Now in the B part of this question, we get C is equal to Q upon V, or Q is equal to CV. In this question is asking about the charge on each capacitor. Okay. So Q1 is equal to C1V. Put the values, then we get Q1 is equal to 2 into 10 to the power minus 10 coulomb. In the same manner, Q2 is equal to C2V. 3 into 10 to the power minus 12 into 100, we get 3 into 10 to the power minus 10 coulomb, and for Q3 4 into 10 to the power minus 10 coulomb. Okay. So now come to the question number 8. In question number 8, question is asking about the capacitance and then charge. So for capacitance, you have the value of permittivity of free space, that is 8.85 10 to the power minus 12, and in question area and separation is given to you. Separation is in millimeter, so you convert this in meter by multiplying 10 to the power minus 3. Then we get C is equal to 17.7 into 10 to the power minus 12, nearly equal to 18 into 10 to the power minus 12 farad. Maybe we can say that 18 pico farad. Okay. Now the charge on capacitor, we get Q is equal to CV. By putting the value, we get the charge is 18 into 10 to the power minus 10 coulomb. Okay. Now the question number 9. In question number 9, one capacitor is given to you and the dielectric is inserted between the plates. The capacitor is same as in question number 8. Okay, but the difference is dielectric is introduced. Okay, so we get the capacitance C is equal to Kc naught and the value of K is 6 and C naught, this is from question number 8, that is 18 into 10 to the power minus 12. By putting the value, we get 108 into 10 to the power minus 12 farad. Okay. In this case, the charge on capacitor is equal to CV. Then by putting the value, we get 108 into 10 to the power minus 10 coulomb. In the B part of question number 9, question is saying that the capacitor is disconnected from the supply. Then the charge remains same, capacitance remains same. What is the potential? Then V is equal to Q upon C, and that is 18 into 10 to the power minus 10. This is from question number 8. And this capacitance is from first part. Okay. This charge is from question number 8 and this capacitance is from first part. And by this we get the potential 16.6 volt. In question number 10, the capacitance and potential is given to you and the question is asking about the energy stored. Simply by putting the values, we get E is equal to 1.5 10 to the power minus 8 joule. Okay. In the question number 11, question is saying that first a capacitor is connected to a potential difference of 200 volt. Means this is supply we get. Okay. So initial energy is equal to half CB square. By putting the value, we get initial energy stored is 12 into 10 to the power minus 6 joule. Okay. Now in the B part, question is saying that supply is disconnected and the capacitor is connected to another capacitor of capacitance 600 picofarad, means equal capacitance, but they are in series and we know the formula for series. 1 upon C is equal to 1 upon C1 plus 1 upon C2 and C1 C2 both are equal, so we get 2 upon 600 and 1 upon 300, means equivalent capacitance is 300 picofarad. Then final energy is half CV square. So by putting value, we get 6 into 10 to the power minus 6 joule. Initial energy is 12 into 10 to the power minus 6. The difference is 6 into 10 to the power minus 6 joule, which we get by subtracting initial energy and final energy. Okay. So this is the answer of B part. Now we can start chapter number 3. The name of chapter number 3 is current electricity. What is current electricity? The study of charges in motion. Charges in motion is called current electricity. Okay, there are two types of electricity. One is static electricity, in which the charges are at rest, and one is current electricity, in which the charges are in motion. Okay, now the first heading is electric current. Most of students know about this. The flow of charge per unit time is called electric current. This is denoted by capital I. That is, I is equal to Q upon T. Here I is electric current, Q is electric charge, and T is time. Okay. The SI unit of current is ampere, denoted by capital A. It is also a fundamental unit. It is measured, current is measured by a device called ammeter. Okay. Ammeter is always connected in series. Okay. Now the direction of flow of positive charge. Once again, the direction of flow of positive charge is the direction of electric current. Always remember this. The direction of flow of positive charge is the direction of electric current. This means current flows in a direction opposite to the direction of motion of electrons. Electron has negative charge, so it moves opposite to electric current. So remember this, positive charge in the direction of current, negative charge opposite to the direction of electric current. Because electric current is the direction of flow of positive charge. So electric current is a scalar quantity. It has no direction. This electric current is the direction of flow of positive charge. Okay. The definition of ampere. The definition of ampere. Ampere is the SI unit of electric current. Okay. So if 1 coulomb of charge is flowing in 1 second, then current is called 1 ampere. That is, 1 ampere is equal to, if we put 1 coulomb in this formula and 1 second, then we get 1 ampere. So 1 ampere is equal to 1 coulomb upon 1 second. Okay. Now Ohm's law. What is Ohm's law? It states that potential difference across the ends of a conductor. This is a topic of 10th class, but also introduced in 12th. So it states that potential difference across the ends of a conductor is directly proportional to the current. Okay, potential difference is directly proportional to current flowing through the conductor when no change in physical conditions, means temperature, pressure remain same. Okay, that is V proportional to I. If we remove the proportionality, then we get V is equal to Ri, or V is equal to IR, where R is proportionality constant known as resistance. Okay, and what is resistance? This is the tendency. It may be property of a conductor, but here we use tendency. So the tendency of a conductor due to which it opposes the flow of current through them. is called resistance. So resistance opposes the flow of current. Okay, that is, from this formula we get R is equal to V upon I. Okay, and SI unit of resistance is ohm, and denoted by this symbol is known as omega. Okay,